For this experiment we require vinegar sample solution, which is a 4% acetic acid, 0.1 normal NaOH solution, Quinhydrone powder, potentiometer, saturated calomel electrode as a reference electrode, and platinum electrode as a indicator electrode, and a salt bridge. There are two parts of this experiment. Part 1 is standardization of NaOH solution and part 2 is estimation of acetic acid from vinegar. Let's perform part 1, that is standardization of NaOH solution. Let's prepare 0.1 normal succinic acid solution. We have 0.59 gram of succinic acid. Transfer and dissolve it in minimum quantity of distilled water. Dilute it in 100 cm cube of standard measuring flask to get 0.1 normal succinic acid solution. Pipette out 10 cm cube of 0.1 normal succinic acid solution in 250 ml of conical flask. Add 2 to 3 drops of phenol indicator and titrate it against burette solution, that is given 0.1 normal NaOH solution till the end point, colorless to permanent pink. Burette reading is 10.7 cm cube. Take 2 more readings and note down the constant burette reading. The CBR is 10.7 cm cube. After doing calculations, the normality of given NaOH solution is observed to be 0.0935 normal. For part 2, do the cell setup as shown in the figure and write the cell representation in your notebook. In one beaker, take saturated KCl solution and dip the saturated calomel electrode in it. In another beaker, take 25 cm cube of diluted vinegar sample solution, add a pinch of Quinhydrone powder and dip the platinum electrode in it. Connect both the half cells by using KCl salt bridge. On your working table, you are provided with vinegar sample solution in 100 cm cube standard measuring flask. Dilute it with distilled water up to the mark. Pipette out 25 cm cube of this diluted solution in add a pinch of Quinhydrone powder into the solution. Stir the solution by using glass rod and insert the platinum electrode into the solution. In another beaker, take saturated KCl solution and dip saturated calomel electrode into it. Connect the two half cells by using a KCl salt bridge. If the ends of the salt bridge are not well within the solution, add a sufficient quantity of distilled water to dip the ends of salt bridge. Do the cell setup like this way. In one beaker, saturated KCl solution is taken and saturated calomel electrode is inserted in it. In another beaker, diluted vinegar sample solution is taken and platinum electrode inserted in it. It is so arranged that we can add 0.1 normal NaOH solution from the burette. Connect both the half cells by using salt bridge. Now do the standardization of potentiometer. For this, connect the standard whetstone cell by pressing this knob. LED will on. As the potential of standard cell is 1.018 volt, the instrument should read 1.018 voltage. If not, adjust the reading on the display by using calibration knob up to 1.018 volt. In this way, standardize the potentiometer. Now to proceed with the readings, disconnects the standard Whetstone cell by pressing the knob. LED is off. Note down the potential of cell. It is 0.152 volt. Do the addition of NaOH with 0.5 ml and stir the solution. Reading will change. Note down the reading continuously. Do the addition with 0.5 ml into the solution. Stir it. And record the potential of the cell. Note down the readings. For 3.5, the cell potential is 0.116 volt. Continue the titration till negative readings are observed. After getting negative readings, note down 5 more readings. Let's see the calculations. These are the potential reading in volts. Let's convert this reading in millivolt simply by multiplying by 1000. Let's find out change in EMF, that is delta E in millivolt. 151 minus 148 equal to 3. 148 minus 137 equal to 11. 137 minus 132 equal to 5. In calculating delta E for negative reading, remember the rules of subtraction, that is A minus minus B equal to A plus B and minus B minus minus C equal to B plus C. Let's understand for these delta E values. 74 minus minus 39, which is equal to 74 plus 39 equal to 113. Minus 39 minus minus plus 50, which is equal to 50 minus 39 equal to 11. Minus 50 minus minus, that is plus 59 equal to 59 minus 50 equal to 9. So let's calculate delta E for all the potential values in millivolt. Now delta V is equal to 0.5 minus 0, that is 0.5. 1 minus 0.5, 0.5. So it is same everywhere. Now find out the ratio delta E upon delta V in millivolt per centimeter cube. That is simply the value in the column delta E by value in the column delta V for the respective readings. 3 divided by 0.5 equal to 6. 11 divided by 0.5 equal to 22. 5 divided by 0.5 equal to 10. Calculate for all the readings. Let's find out mean volume. That is the average of two successive volumes. 0 plus 0.5 divided by 2 equal to 0.25. 0.5 plus 1 divided by 2 equal to 0.75. 1 plus 1.5 divided by 2 equal to 1.25. 1.5 plus 2 divided by 2 equal to 1.75. In the similar manner, the successive mean volume are 2.25, 2.75, 3.25, 3.75, 4.25, 4.75 and so on. Let's plot the graph of delta E upon delta V versus V mean. Plot V mean in centimeter cube on x-axis and delta E upon delta V in millivolt per centimeter cube on y-axis. Take the proper scale. Here for these observations, on x-axis 1 centimeter equal to 1 centimeter cube and on y-axis 1 centimeter equal to 15 millivolt per centimeter cube. Now plot the points. Plot all the points at their respective position. and connect all the points to get the sharp peak. From the highest delta E delta V point, draw the tangent in the direction of x-axis and connect the points to the left hand side and right hand side of these tangents, and connect the remaining point by a smooth hand to get a peak with smooth curve. Find out equivalence point of the titration, that is Vx equal to 7.25 centimeter cube. From the graph, Vx, that is volume of 0.095 normal NaOH required for neutralization of 25 ml of diluted vinegar solution is 7.25 centimeter cube. Stoichiometrically, 1000 centimeter cube of 1 normal NaOH is equal to 60 gram of acetic acid, and therefore 4 into Vx centimeter cube of a normal NaOH will require 0.1653 gram of acetic acid. Let's calculate the percentage error. The true value for this amount of sample is 0.166 gram, and hence percentage error is observed to be minus 0.421%. Thus the results are normality of given NaOH solution equal to 0.095 normal. The volume of given NaOH required for neutralization of 25 ml of diluted vinegar solution is 7.25 centimeter cube. The amount of acetic acid present in the given vinegar sample is 0.165 gram, and percentage error is observed to be minus 0.421%.